let's continue on with our Unit 7, Part 2 review. We are on number 13. So this question is asking for all the real zeros of this equation. Okay, so real zeros are where the graph is touching the x-axis. If it's not touching the x-axis, then those are imaginary. Okay, so I'm going to put that big long sucker in my calculator. X to the fourth plus 17x cubed plus 121x squared plus 433x plus 328. Those are some big numbers. Okay, so we're not seeing a lot of the graph. Okay. This one looks like 1, 2, 3, 4, 5, 6, 7, 8. That one looks like -8. I'm going to verify in the calculator in a second. And this one looks like -1. And I'm going to verify in the calculator. Okay, so let's look. -8 is an answer because there's a 0 there. And -1 is an answer because there's a 0 there. Just trying to see what else happens. Okay, so that looks like those are the only real zeros we have. So since it only touches the x-axis twice, there's only 2 real zeros. We know that there's supposed to be 4 answers total, so that means the other 2 are imaginary. So we have 2 real, which are these guys, and we have 2 imaginary, which if I wanted to know what the imaginary ones were, then I would need to do synthetic division with these 2 answers, and then I would have to solve from there. But it's not asking for that. It's just asking to find all the real zeros. And so first it wants the smallest root, or the smallest 0. So -8 is our smallest 0, or smallest root. And then it wants the largest root, or the largest 0, and -1 is the largest one. So that's the smallest, that's the largest. And the other 2 answers are imaginary, which is why we're not seeing it touch the x-axis. Okay, this next one. All right, it gives us an equation, and it's saying which statement is true concerning f of x and the inverse. So this is wanting to know something about the inverse. And it wants to know just which statement is true. Okay, so the first 2 answer choices look a little confusing. So let's see if C is correct or if D is correct, because those are pretty easy to understand. Okay, so first I'm going to put this equation right here in my calculator. So go to math, go down to number 4. There's my cubed root of x plus 1. I need a right arrow to get out of the cubed root, and then -2. Okay, let's look at it. Now, I'm not looking at this one and the inverse. I'm just looking at this one. Now, look at answer choice D for a second. D says that f of x and the inverse will intersect at 0, 0. Well, all I've graphed is f of x. But does it even go through 0, 0? No. So if I put the inverse in, and let's just say it looks something like this, it's not going to intersect at 0, 0 if this one's not even going through 0, 0. So it can't be D, so D's out. Now C is really easy to figure out. It's asking if the x-intercept of f of x is 7. So it's asking, does this graph touch the x-axis at 7? It's hard to tell from the picture, so let's go to the table. So I'm going to go to where x is 7, and sure enough, there's a 0 there. So yes, the x-intercept of this graph is 7. So that's what this is saying, the x-intercept of f of x is 7. Okay, so if I made a table for f of x, right, and the point is 7, 0, that's the x-intercept. Well, do you remember how the inverse switches the x and y's? So if I switch the x and the y's, flip, this would be 0, 7. Well, when the y is 0, that's an x-intercept. But when the x is 0, that's a y-intercept. So that means if I graph the inverse, the y-intercept will be 0, 7. And let's look what this says. The y-intercept of the inverse is 7. And yeah, the y-intercept of the inverse is 7. So that's my answer. It wanted to know which statement was true, and that statement is clearly true. So I don't even need to look at A and B. All right, moving on. Okay, a cubic function is shown below. Which of the following are representations of the inverse of f of x? All right, well, we need to find the inverse to know. So remember, f of x is a fancy y. We need to switch the x and the y around. So this y becomes an x, and this x becomes a y. Okay, now we need to solve for our new y. So I need to get this y that is raised to the third power, I need to get that by itself before I can get rid of the cubed. So to get rid of this addition of 3 that's in the back, I need to do the opposite and subtract. You can't subtract x minus 3, so we just leave it. And the right side, y minus 1 cubed, just comes down. Okay, so now I'm ready to get rid of my cubed. So to get rid of a cubed, we cubed root. So I'm going to cube root both sides. On the left side, I can't do anything with that, so that's just going to stay cubed root of x minus 3. And on the right side, the cubed and cubed root cancel, leaving y minus 1. And then to get y by itself, I get rid of subtraction of 1 by adding 1. And I can't add 1 to this because this is under the cubed root and this isn't, so I just recopy it all. So I've got cubed root of x minus 3 with a plus 1 in the back. And that's my inverse. So first let's see who said the inverse is what we just got. This says the inverse is cubed root of 2x minus 3. Okay, no, you're not it. This says the inverse is 2. No, that's not it. There's no 2. Where's those 2's coming from? They all have a 2 in here. Huh. I wonder if those 2's are typos. I'm thinking those 2's are typos. Very interesting. Okay, well, I declare I don't like this problem. If I had to pick which one it would be, the one that most looks, well, none of them really look like it. I'm so sorry. I don't know what's wrong with this problem because there's no 2's. There were no 2's in this problem to have a 2 here or a 2 here. So these 2's should not exist. I'm sorry, this is a bad problem. There must be a typo in this problem. So I'm sorry about that. There should be no 2's. This is what your inverse should look like, and none of those say that. Okay, sorry about that, guys. Okay, number 17. Carlo and Monty were working on homework and solving this equation. Carlo solved and got the answer 2, and Monty solved and got the answer 16. Okay, well, let's see who's right. Okay, so they're just solving this equation. So we're trying to get x by itself. So eventually we'll get rid of the cubed root, but first we have to get rid of subtraction of 3. So we're going to add 3 to both sides. The cubed root of 2x plus 5 comes down. And on the right side, 0 plus 3 is 3. Okay, so now to get rid of the cubed root, we cube. So I'm going to cube this side and cube this side. So on this side, 3 cubed is 27. And on this side, the cubed and cube root cancel, leaving 2x plus 5. Okay, now it's pretty easy. What would you do? Subtract 5. If you subtract 5, you get 22. And then what would you do? Divide by 2. And if you divide, you get 11. Well, look, neither boy's right. Carlo got an answer of 2. He's wrong. Monty got an answer of 16. He's wrong. So, D, neither student is correct. Sorry, boys, you need to study a little bit more. Okay, question 18. All right, wants me to solve this. Okay, so first thing I'm going to do is clean that up. 4 cubed. 4 times 4 times 4. Well, that's 64. And then I'm going to leave this 8x cubed. Okay, I'm trying to get x cubed by itself, and then once it is, I'll cube root. So I'm going to get rid of the 8. So I'm going to divide both sides by 8. And then you're left with x cubed equals 8, because 64 divided by 8 is 8. And then to get rid of a cubed, you cube root. So I'm going to cube root both sides. And the cubed root of 8 is 2, because 2 times 2 times 2 is 8. So 2 is our answer. Okay, 19. Which of the following is not true? Okay, so they're talking about linear factors. Okay. Oh, and then this one says something about a y-intercept. Okay, so I am going to graph it and see what I can find for the zeros, which leads to the linear factors. All right, so I've got x cubed minus 2x squared minus 7x minus 4. Okay, let's see what we get for real zeros. Okay, so it looks like it's touching at -1, and it looks like it's touching at 1, 2, 3, 4. So it looks like -1 and 4. Let's see. -1 is an answer because it has a 0 in the y column, and 4 is an answer because it has a 0 in the y column. Okay, so those are our zeros. So the linear factors, remember, are the opposite signs. So if -1 is a 0, x plus 1 is a factor. And if positive 4 is a 0, x minus 4 is a factor. Okay, so let's see what this is saying, which is not true. This says x plus 1 is a factor. Okay, that's true. This says x plus 4 is a factor. Okay, I don't agree. This says x minus 4 is a factor. Okay, that's true. Let's see if 0, -4 is the y-intercept. Oh yeah, here's 0, -4. And that is the y-intercept because that's where the graph is touching the y-axis. And y-intercepts always have a 0 for the x, so that is also true. Now, this one is not true because if x plus 4 was a factor, then -4 would be a 0. And this graph is not touching the x-axis at -4. You can also tell in the table that -4 is not an answer because there's not a 0 in the y column. So if -4 is not an answer, then x plus 4 won't be the factor. Okay. All right, next one. I'm just solving this. And since all of this is raised to the 1/3, I'm ready to get rid of my 1/3. So we do the reciprocal exponent, flip. And the reciprocal exponent is 3/1. So I'm going to raise this side to the 3/1, which is the same thing as 3. So the 1s and 3s cancel out. Shoop, shoop. All you're left with is 5x plus 1. And then 6 cubed, 6 times 6 times 6 is 216. Just to show you. 6 cubed, 216. Okay, and then to finish solving this, I get rid of addition of 1 by subtracting. So when I subtract, I get 215. And then to get rid of multiplication, I divide. So I'm going to divide both sides by 5. So I'm taking 215 and dividing by 5. And that is 43. So 43 is my answer, and 43 is what I would type in if I was typing things in. And that's it. And that's your review to the Unit 7 Part 2. Review. That's your video. All right, good luck on your test, everybody.